Hey everyone, in this video, let's go to question 253, meeting rooms 2 on Leetcode. This is part of a blind 75 list of questions, so let's begin. So this question is actually a premium question, and that's why we're doing it on this Leetcode website. That's why the number here is different, but otherwise the question and the test cases solution will all be the same. So let's go ahead and begin. In this question, we're given an integer or given an array of meeting time intervals consisting of start and end time, so S1, E1, S2, etc., where SI is less than EI, and we want to find the minimum number of conference rooms required. We can see here that additionally, 0, 8, and 8, 10 is not a conflict, which means that a meeting can end and another one can start at the same time. We essentially want to find the minimum number of conference rooms required. Now, we've done a question similar to this, meeting rooms 1, and in that one, essentially, we just had to figure out if one conference room could fit every single meeting. And so in that one, we just looked for an overlap, and if there was any sort of overlap, we understood that we could not have the scenario. In this one, we're asked something similar, but instead, we want to find the minimum number of conference rooms required. So if there is an overlap, we'll basically add in another conference room, and then we can see based on that how we can arrive at the solution. Okay, so let's take a look at the examples here to better understand. And again, this website is used for premium problems, so we will use it anytime we have a premium problem on Leetcode. Let's take a look at what we have here. So in this one, what we have is we have a couple of meeting rooms, right? Or meeting like times, 0 to 30, 5 to 10, 15 to 20. And what is one thing we want to do, right? So if you think about it, like these times mean something, right? This means that we must start off at time 0. This means that we must start off at like time 5. This means we must start off at time 15. Maybe you can think of this as like 12 o'clock. This is like 12:05. Maybe this is like 12:15 or like whatever, right? But basically, meetings have to happen in a certain order. Like similar to real life, meetings have to happen in a certain order. So one thing we might want to do, and we did this in meeting rooms 1, is kind of like sort this list, right? Because this list isn't actually sorted based on anything. But what we did in meeting rooms 1 is we sorted it based off of the starting time. Why does this make sense? Well, this makes sense because in real life, you want to take in meetings based on the starting time, right? Like you want to pick the earliest meetings first. So that's one thing we'll have to do. So we'll have to sort the meetings based off the starting time. And really, if you think about it, right, it kind of makes sense, right? If I'm just going through this and I want to see how many, like first of all, if there's any overlaps, well then I would take a look at this one, and then I can see it starts at 0, ends at 30, and then this one definitely there is an overlap because this last meeting hasn't finished yet, right? And so if you think about it, so we definitely need to do that, right? So we definitely need to sort based on start times. Okay, so what else? Well, in this question, we're asked to figure out the minimum number of meeting rooms that are required, like the conference rooms that are required. So how can we do this? Well, we know that like the initial meeting room we process, right? That's gonna have like its own room. That's gonna have its own room. Okay, so we know that. And what we also know is that this room is gonna be used until this time 30, right? So for example, if I process this one and then I go on to this one, I basically have to understand that like currently there's only one meeting room and that meeting room is ending at time 30. So there's no way that I can process this one in the same room. So this one has to come inside its other room. This one has to come inside another room. Okay, so we've done that. Now what about this last one over here? Well, this last one, I kind of have two options, right? I could either choose from this meeting room, I could choose from this meeting room, or maybe like I'd have to create my own meeting room. So what can we do? Well, when we're on this one over here, we have to essentially determine that, okay, there's a meeting room that has a time ending of 30. There's a meeting room that has a time ending at 10. Now, what can we understand from this? Well, you can understand that from the meeting room that has a time ending at 10, then I can actually take its place, right? Because my start time is 15. And because we've sorted based off the start times, it means that I can essentially like take this meeting room's place because this meeting is done and I can take its place. And so after I do that, meeting 2, room 2 will just have these two meetings here. So what does this kind of like remind us of, right? Like if you think about it, on any specific meeting, we need to know all of the ending times, right, that are available. And we want to essentially pick the smallest ending time, right? Maybe this time ended at like time like maybe 9 or something. And so we would actually go ahead and pick this time. We would evict this one and we would replace room 1 with this thing over here, right? So what does this kind of remind us of when we want to pick the smallest time? Well, if you think about it, the solution is a heap, right? We can use a heap data structure. So how might the heap work? Well, basically what we could do is that if the heap is empty, then we know that there are no meeting rooms. So we add to the heap. What do we add? well, we want to sort based off of, or we want to extract based off of the minimum ending time, right? If I'm over here, I need to figure out which one of the rooms essentially ended first, right? Like which one of the rooms like doesn't have any meetings anymore, and that's determined by the ending time, right? That's determined by the ending time. It's not determined by the starting time, because the starting time might be like a super high value, but if the meeting ends in like 1 minute, well, that's our main focus, right? So if you think about it, what we can do is once we sort based off the start time, then add element to heap based on ending time, and then when adding new element, check if we can pop from heap, meaning old meeting has finished, right? So what does this mean? Let's maybe take a look in the code to kind of see what I'm saying here, but hopefully this step that we have over here can easily explain it. But okay, so what do we need? Well, we need a heap, right? So we can do like from heap q, import heap pop and heap push. Okay. What else do we need? Well, we need our heap, which I just call this, and then I need to go through my intervals, right? So I need to go through my intervals. So I will do for interval in intervals. Okay, so now I'm processing this first one. Now what do I understand? Well, I understand in the first one, actually, first thing actually we need to do is sort it based off of the start times, right? So maybe we can do intervals is sorted intervals, and the key is based off of x.start, right? And it's because it's a list of intervals, so intervals is actually a class over here, so you can see we have the start and the end. So that's why we have that. Okay, so after I've done that, I can go ahead and loop through my intervals, and now what? Well, this first interval that I have no like meeting rooms, right? You can think of this heap as storing the amount of meeting rooms that we can have at a specific time. So this heap over here, if you think about it, if heap is empty, so if not heap, then no meetings, no meeting rooms, create one. So what we can do is we can increase our count. So maybe we'll start off our count at 0, and then we'll return our count in the end. This is the count of meeting rooms. And then what? Well, then we need to go ahead and we need to add. How do I turn off autocomplete? Can I do that? Because turn it off. Getting annoying. Yeah. So if we are going to be using a meeting room, well, then we have to add it to our heap. So I can do heap push h, and then what do I need to add? Well, remember, we want to pop based off of the earliest, the smallest ending time. So we will pop based off the ending time. So I'll do interval.e and then interval.s. So what is this going to do? Well, to the heap, what it's going to add, essentially, it's going to add in the value 30 and then 0. And then, for example, if we go ahead and we process this element here, right? So maybe if heap is not empty, then check if any items finished, right? So how do I determine that? Well, I can check if heap at 0, right? Heap at 0 will essentially be the item that has the smallest ending time, If this item that we have, right? If this is, so this is the ending time, right? This is the ending time, ending and starting. So if the ending time of the meeting, if this is somehow less than or equal to the starting time of my current meeting, right? So listen to this carefully. If the ending time of this meeting, which is based off of this first element here, if this meeting has ended before our meeting has started, well, then I can go ahead and use this room, right? So what I can do is I could just do heap pop, and I will pop heap pop, and I will pop from the heap, and I don't actually care about the value. But then what I could do is I could append to the heap. I will do heap push h, and then what do I want to append? Well, I want to append this same thing over here. I will append the starting time and the ending time based off of my information here. Now, in this case, we actually won't go ahead and actually here, if you think about it here, we don't need to increase the res, right? Because we're using the same meeting room, so we don't need to do that. But let's just kind of take a look at like what this might look like. In the first case, our heap just has this value here, right? Heap just has this. And so what we do is we check to see if the ending time is less than our starting time, which in this case is 5. It's not. So what we're going to do is we're going to append 5 and 10 to the list, to the heap, but we'll append it in reverse order. And so now we have 2 meeting rooms, right? And so I guess here, if it's else, right? If it's else, this means we cannot use existing meeting room So create own. And I guess this thing here, actually, we need this, and we need it over here as well. But here we will actually append to res, right? Here we will append to res. So what we're doing here is like we're pushing regardless. We're pushing regardless, right? Because maybe in this case I'll replace it. Maybe in this case I have to add it, but we're pushing regardless. But if I have to add it, then I want to increase my res. Okay, so what happens at this point? Res is equal to 2. And then when I go to process this element here, this meeting room over here, I can see that heap at 0 will actually be reordered. The heap will be reordered to something like this. Why? Because it's ordered based off of the ending time. And the ending time here is 10. And so when I look at this, I can see that 10 is less than or equal to 15. And so what this means is that this room over here can be replaced by 15 and then 20. And so that's why this will actually give us the minimum amount of room that we need. And so you can keep doing this, but in the end, we'll arrive at our solution. So let's take a look at the test cases to see that they pass. So this should be end, start, start, and then end, and then start. Heap is not defined. Where am I doing that? Heap at 0. So I guess it should be h at 0. And between tuple and int. Yeah. H at 0. Oh, I guess h at 0 refers to the actual like heap itself, right? So like this value here. So we actually need h at 0 at 0. So that will give us the start time, right? And so then we can go ahead and submit it. And then we can arrive at the solution. Perfect. So don't really worry about the percentage beat. This is actually like the efficient solution here. So what is the time here? Well, if you think about it, for the time and space, we have to concern ourselves with the heap itself, right? So in the worst case, I need to add in everything to the heap, right? Because there's an overlap every single time. So if I add in everything to a heap, then I'm doing a heap push. That is a log n time. And essentially, like, I would also, maybe I don't need to do a heap pop, but assuming like I do need to do a heap pop, then it would be like n log n, right? And actually, like by sorting here, it is also n log n. So really, it's still dominated by the sort over here. But in terms of the space, you can kind of think of the space as O of n, because at the worst, like we will add in all of the items onto the heap. The time is n log n, the space is O of n. Okay, thanks for watching.